Hello everyone, you are welcome to today's class. So today we are going to be looking at matrices. So under this topic we are going to be looking at these following objectives. So the first one is definition, that is the meaning of a matrix. Then the second one is order of a matrix. Then the third one is types of matrices. Then the fourth one is notation of matrices with examples, while the last one is addition and subtraction of matrices. So starting with the first objective, that is the definition of a matrix. So what is a matrix? A matrix is a set of numbers arranged in rows and columns to form a rectangular array or pattern and enclosed inside a curved bracket. So let me take it again. A matrix is a set of numbers arranged in rows and in columns to form a rectangular pattern or array and enclosed inside a curved bracket. So that is the definition for what? For a matrix. And we define that as any given number such as a set of 2, 3, 4, 5, 6, 7. So this is type of a matrix. So a matrix is given as set of numbers in rows, arranged in rows or in column, so as to form a rectangular pattern or array. And this rectangular pattern are enclosed in a curved bracket. So that is the definition of a matrix. So the plural form of a matrix is known as matrices. So the singular form is matrix, while the plural form is a matrices. So is matrices. So after the definition, we move to the order of a matrix. So order of a matrix simply means the name of the matrix. So we name the matrix according to the order of a matrix. So let's take, for instance, we have, after the definition, we have the order of a matrix, then the order of a matrix. So let's have it like this. So order of a matrix. So the order of a matrix is given that a matrix has n rows and n columns. Then the order of this matrix is n times n, written as, or read as m by n. So the order of the matrix simply gives the name to the matrix. So if you have m rows and n column matrix, so the name of that matrix is m by n matrix. So let's take, for instance, e.g. So if you have matrix A, which is 2, 3, 4, 5, 6, 7. So the order of this matrix is the order of matrix A is the number of rows. We are starting with the number of rows. So how many rows we have there? Here is the first row, here is the second row. That is 2 rows and 1, which is the column, another column, then another column, making 3 columns. So 2 rows and 3 columns. So the matrix A is 2 by 3 matrix. So according to the order of matrix. I've told you the order of the matrix is just the name of the matrix and depends on the number of rows and the number of columns. So since in matrix A here we have 2 rows, so we are going to have 2 by 3 matrix. So that is the order of matrix A as we have it in this example. So the next one is types of matrices. So we have various types of matrices, but for the purpose of this class, I'm going to consider only 6 types of matrices. So the first one, so under this we have types of matrices. So the first type to be considered is row matrix. So row matrix. A row matrix simply means a matrix with single row. Matrix with what? Single row. E.g., 2, no bracket inside the bracket. I mean, no comma inside the bracket. So we have 2, 3, 0, 1. So this is row matrix, and the name of the matrix, you can say let A be the matrix 2, 3, 0, 1. So we name this matrix 1 by 1, 2, 3, 4. So with the name of the matrix A, the name of the matrix A is 1 by 4 matrix. 1 by 4 matrix. So which is row matrix. So the second types of matrices is column matrix, and we have it as column matrix. So what do I mean by column matrix? So this is a matrix with only single column. So we can have many rows but one what? Column. E.g., matrix B is equal to 1, 0, 4. So this is a column matrix because we have a single column, and the name of the matrix is, and its name is 1, that is 3 by 1 matrix. So that is for column matrix. So after the column matrix, we have number 3, that is square matrix. So square matrix. So in square matrix, the number of rows and columns are the same. So number of columns and rows are, or number of rows and columns are the same. That is for column matrix. E.g., let's take for instance matrix C, which is equal to 2, 4, 1, 3. So if you take note of this, the number of rows, we have 2 rows and we have 2 columns. So in this case, we have that is 2 by 2 or 3 by 3 matrices are what? Are square matrix. So this is example of square matrix. Then the next one is 0 or null matrix. So under 0 and null matrix, all the entries, that is all the elements in the given matrix, they are all 0. That is 0 matrix. So e.g. matrix D that has all the entries to be what? To be 0. This is known as null or 0 matrix. Then after this, we have number 5. We have diagonal matrix. So under diagonal matrix, so the example of diagonal matrix is, let's say we have 3, 0, 0, 4. So this is example of diagonal matrix. In 2 by 2 matrix, as we have it under square matrix, we have 2 main diagonals. I mean, we have 2 diagonals. We have the main diagonal, which is the leading diagonal, or we call it principal diagonal. Then we have the other diagonal, that is the second diagonal. So under diagonal matrix, the principal diagonal it has value, but the other diagonal, the entries there, they are what? 0. That is diagonal matrix. And we have this example, that is the main diagonal, which is the principal diagonal, we have 3, 4, which is the element, but under the other diagonal we have 0 as the entries. So we are going to continue from the example, type 6. So the last types of matrices I'm going to consider is unit matrix. Unit matrix. Under unit matrix, the principal diagonal is 1. So under unit matrix, that is the element of principal diagonal, they are all units. That is 0. The other diagonal can be 0. So it's not going to be matrix D or matrix E, which is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. So we call this unit matrix. That is the entry here under the main diagonal or principal diagonal, they are all what? 1. That is for the types of matrices. So the next objective we are going to consider is notation of matrices with examples. So under this notation of a matrix can be denoted by bold capital letter, while the element under the bracket can be denoted by small letter, e.g. For example, so let's consider matrix A. So this is the notation of the matrix. So we've denoted this matrix by capital letter A. So the matrix can be denoted by capital letter A, which is equal to, then the element under the matrix will now be denoted by small letter. So we can have it as A, B, C, D. So these are the elements, these small letters are the elements inside the matrix A. So this is how we denote the matrices with the element inside the matrix. Then the next one is what? Under this notation, we are going to be looking at the position of each of the elements under the matrix given. So the position of the matrix and the notation of the matrix, they go concurrently. So the position of, let's take for instance, for example, the position of 2 in matrix B, which is equal to 2, 4, 3, 1 is, so if you have to go by this question, the question says the position of 2 in the matrix B, which is matrix 2, 4, 3, 1. That is 2 by 2 matrix is B, 1, 1. So why is it B, 1, 1? So we are going to, the first one here, explain the first row. That's the first row and the first column. That's why we have B, 1, 1. So the position of 2 will be the number of rows, it falls on the first row, but on the second column. So the position of 4 will be B, 1, 2. Then the position of 3 will be, that is 3 falls on the second row, but first column. That is 2, 1. So the position of 3 will be B, 2, 1, while the position of 1 on this matrix will be B, 2, 2. So that explains notation of matrices with example. So that's how we denote the position of each of the elements in the given matrix. So that is that on. So under this, I'm going to look at this example. And the question says, so examples on notation of matrices. So question 1 says, given that matrix A equal to 0, 4, 1 minus 1, and 0, 3. So after the explanation of notation of a matrix, so we move to examples on notation of matrices. And the question says, given that matrix A equal to 0, 4, 1 minus 1, and then the second row is 0, 3 minus 2, 5, and matrix B is 1, 2, then minus 2, 4. So the first question says, state the order of A and B. That is order of matrix A and matrix B. So I've told you the order of matrix A and B, just the name given to matrix A and B. So the name of the matrix A and B depends on the number of rows and the column. So question A, solution A. So state the order of a matrix. So order of A is, so the name of matrix A, that is depends on the number of rows. We have the first row and the second row. That is 2 by how many columns? 1, 2, 3, 4. So we have 4 columns. So matrix A is 2 by 4 matrix. So that is the order of matrix A, which is the name given to matrix A. Then the second part, that is the order of matrix B. So order of matrix B is depends on the number of rows and the number of columns. So we have first row, second row. So that means order of B is 2 by 2 matrix, because here the number of rows and the number of columns are the same. So we name this type of matrix 2 by 2 matrix, which is also known as squared matrix. Then the question B states that determine Roman figure 1, A1, 3. So we are working under matrix A. So A1, 3 means the first row and the third column. First row of matrix A and the third column. So the first row is this, then the third column 1, 2, 3. So we have 1. So A1, 3, that is the position of A1, 3. The number that is there is what? 1. So A1, 3 is 1. Then the second one is A22. So A22. So we are still working under matrix A. So A22 means the first two stand for the second row and second column. So second row and second column. So here's the first row, here's the second row. So we are working under the second row, but what? Second column. So here's the first column, second column. So we have this. So here's the second column. So the position of A22, the number we have there is what? 3. Then the third one, we have A23. A23 stands for the second row and third column. So we have the second row, here's the first row, second row. So we are working under the second row, but what? Third column. So here's the first column, second column, third column. So we have -2 at that position of intersection. So we have -2. So that is then question C. Question C says, what type of matrix is B? So what type of matrix is B? You check, before you can know the type of matrix, you check the number of rows and the number of columns. So we have number of rows to be 2 and number of columns to be 2. So that is 2 by 2 matrix. Then, which is, it is called square matrix. Square matrix. Why? Because the number of rows, is 2 by 2 matrix. That that is the number of rows is equal to the number of columns. So that is that on examples on notation of matrices. So thank you. We move to the next one, which is addition and subtraction of matrices. Now, so we continue from where we stop. That is, we stop at notation of matrices with examples. So we move to addition and subtraction of matrices. So before I go to the example, I just like to explain addition and subtraction of matrices. Two matrices can be added or subtracted only if they are of the same size. What do I mean by size? That is their order. So you cannot add or subtract 2 by 2 matrix from 3 by 3 matrix. They are not of the same order. Or you cannot subtract 2 by 3 matrix from 3 by 2 matrix. They are not of the same order. So before you can add or you subtract, the two matrices must have the same order. That is either 3 by 3 or 2 by 2 or 4 by 1 or 4 by 1. So they must have the same order before you can add or you subtract one matrix from another matrix. So I think with this we are going to move straight to the example. With that small explanation, we'll be able to tackle the given question. So we move to the example. So the question says, given that
echo question.
So okay, example. So after the explanation on addition and subtraction of matrices, don't forget, before you can add or subtract any matrix from another matrix, they must have the same order. So that will lead us to the example. And the question says, given that A, that is matrix A, equal to 3, 6, 4, 2, 1, 0, minus 5, 2, 3. Matrix B is 2, 5, 5, minus 3, 0, 4, minus 4, 8, 2. So the question now says, determine Roman figure 1, A plus B. Roman figure 2, B plus A. Roman figure 3, A minus B. And Roman figure 4, B minus A. So let's go to question A, Roman figure 1. Question A first. So question A says, we have to determine the addition of these two matrices. But before we can determine that, you check the order of matrix A and matrix B. So the order of matrix A is, so order of matrix A is 2 by 2 matrix. I mean it's 3 by 3. Where I can cut it.
So order of matrix A.
Okay. So we move to the example. And so solution. So the question says what? A plus B. So Roman figure 1 is A plus B. But before we can add A to B, you check the order of matrix A, which is, if I check, we have 3 rows and 3 columns. That is 3 by 3 matrix, that is order of matrix A. Then matrix B is also 3 by 3 matrix. So we are allowed to add and subtract because they are of the same order. So we now move to matrix A and B, that is A. Matrix A is given as 3, 6, 4. Matrix, that is the first row. Then second row, 2, 1, 0. Then the third row, minus 5, 2, 3. Then plus the second matrix, that is B. We have 2, 5, 5. 2, 5, 5. Then the second row, minus 3, 0, 4. Then the third row, minus 4, 8, 2. So the next thing to do is to add the corresponding elements together. So here, so the first element here, which is A11, we are going to have 3 plus B11, that is 2. Then that is A12, 6 plus 5. Then the next one is 4 plus 5. So that is for first row. Then the second row, 2 plus minus 3. Then the second element of the second row, 1 plus 0. Then the third element of the second row, that is 0 plus 4. Then the last row, we have minus 5 plus minus 4. Then the second element, 2 plus 8, while the last element is 3 plus 2. So we have 3 plus 2, that's 5, 11, 9. 2 plus times minus is minus, so 2 minus 3, that is minus 1. 1 plus 0, 1. 0 plus 4, that's 4. Then plus times minus is minus. Minus 5 minus 4 gives us minus 9. Then 2 plus 8, that's 10. Then 3 plus 2, we have 5. So the addition of matrix A and B give us this answer. That is for Roman figure 1. Then Roman figure 2, B plus A. So we are going to follow the same process, but we are going to write matrix B before A. So we have 2, 5, 5, minus 3, 0, 4, minus 4, 8, 2. That is for matrix B. Then plus, this plus, put it in between. Then matrix A, that's 3, 6, 4, 2, 1, 0, minus 5, 2, 3. That's for the third row. Then we add the two together. So we have adding the corresponding element. That's 2 plus 3, 5 plus 6, 5 plus 4. Then the next one is minus 3 plus 2 is 0 plus 1, then 4 plus 0. Then for the third row, minus 4 plus minus 5, then 8 plus 2, then 2 plus 5. So which is equal to, that's 2 plus 3. Then which is equal to, so 2 plus 3, that's 5. Then 5 plus 6, that's 11, 9. Then minus 1, 0 plus 1, that is 1. Then we have 4, that is 4 plus 0. Then plus times minus is minus. Minus 4 minus 5 gives us minus 9. Then we have 10 here. Here we have 5. So the addition of B to A, that is B plus A, gives us 5, 11, 9, and so on like that. Then, so after Roman figure 2, which is B plus A, so we move to the next question, which is A minus B. That is Roman figure 3. A minus B. So we start, this is subtraction of a matrix from another matrix. So we have matrix A to B, 3, 6, 4, 2, 1, 0, minus 5, 2, 3. Then minus second matrix, which is matrix B. So we have 2, 5, 5, 2, 5, 5. Then we have minus 3, 0, 4, minus 4, 8, 2. So we now subtract B from A. So which is equal to, so subtract the corresponding element, that is 3 minus 2, 6 minus 5, 4 minus 5. So that is the first row. Then the second row, 2 minus 3, 1 minus 0, then 0 minus 4. That's the second row. Then the third row, minus 5, minus 4, then 2 minus 8, then 3 minus 2. So which is equal to, so let me rewrite it. So which is equal to 3 minus 2, that is 1. 6 minus 5, that is 1. 4 minus 5, that is minus 1. Then the second one, minus times minus is plus. So 2 plus 3, that's 5. Then 1 minus 0, 1. 0 minus 4, that's minus 4. Then the last row, minus times minus is plus. Minus 5 plus 4, that is minus 1. Then 2 minus 8, that is minus 6. Then 3 minus 2, 1. So we have this matrix for A minus B. Then the next one is B minus A. So B minus A, Roman figure 4, B minus A, which is equal to, so we are going to write matrix B.
Okay.
So we are done with Roman figure 3, which is A minus B. So we have this answer. So we move to the next one, which is B minus A. So we are going to write matrix B. So we have 2, 5, 5. Then that's first row. Second row, minus 3, 0, 4. Then the third row, we have minus 4, 8, 2. So I'm using this. So we have this. Then minus matrix A. So matrix A is given as, matrix A is given as 3, 6, 4. That's first row. Second row, 2, 1, 0. Then the third row, minus 5, 2, 3. So we are subtracting matrix B, matrix A from B. So we are subtracting matrix A from B. So which is equal to, so we continue by subtracting matrix A from B. So we have 2 minus 3. That's the first element in the first row. Then 5 minus 6. Then the next one is 5 minus 4. Then go to the second row. Minus 3 minus 2. Then the second element in the second row is 0 minus 1. Then 4 minus 0. Then the third row, minus 5. Minus 4. Minus, so minus 4, minus, so minus 5. Then the second element, 8 minus 2. Then the third element in the third row, that is 2 minus 3. So we add it as this. So which is equal to, so we give rise to our final answer. So we have 2 minus 3, that is minus 1. 5 minus 6, minus 1. 5 minus 4, 1. Minus 3 minus 2, that's minus 5. 0 minus 1, that's minus 1. 4 minus 0, that's 4. Then the last row, minus times minus is plus. Minus 4 plus 5, that is 1. Then 8 minus 2, that's 6. Then 2 minus 3 gives us minus 1. So that is solution to B minus A. So we move to the last question, which is, what can you deduce from your result in part A? So the result we have in part A, the result to A plus B, result to B plus A, result to A minus B, and result to B minus A. So let's compare, let's check the result from Roman figure 1 and 2 under question A. If you check Roman figure 1 and 2 under question A, we notice that the answer to A plus B is the same thing as the answer to B plus A. So if you check the first row, we have 5, 11, 9. The same thing here, 5, 11, 9. Then minus 1, 1, 4, minus 1, 1, 4, minus 9, 10, 5, minus 9, 10, 5. So we can now conclude that matrix A plus B, so question B, so we conclude that A plus B equal to B plus A. That is, they are commutative. They are commutative. That is, A plus B equal to B plus A, according to the result given from figure 1 and 2. Then the second part, A minus B. So we have this result for A minus B, and we have this result for B minus A. So let's now compare the two results. So for the first row under A minus B, we have 1, 1, minus 1. Here we have, that is the first row under the second, that is B minus A. We have minus 1, and 1. So the first row is wrong. So once one of the elements are not the same, one of the corresponding elements are not the same, it means the two matrices are not equal. So they are not equal, which means they are not commutative. So we can now conclude that A minus B is not equal to B minus A. That is, they are not commutative. They are not commutative. So, thank you. It means the matrices addition is commutative under matrices, but subtraction is not commutative under matrices. So thank you. So if you enjoyed this class, I want you to give us the thumb up and subscribe to the channel for more updates. So thank you.